on solving systems of equations algebraically. In the last lesson, we solved systems of equations through graphing, and there's other methods than just doing that. Sometimes graphing is not feasible and you could just do it algebraically instead. So there are two methods in solving systems of equations algebraically. You could either use the substitution method or the elimination method. Most of the time, it's up to you which one you want to use. It's whatever you feel most comfortable with, but you still should know how to use both. So the first example, we're going to solve this system of equations. 5x minus y is equal to 10, and x squared plus x minus 2y is 0. Then when you're done, we want to verify the solution. So let's focus on doing substitution first. The first thing I want to do in substitution is rearrange one of the equations. I'm going to call this A, and I'll call this one B. Rearrange A or B to solve for just x or just y. So in this case, I'm just going to pick equation A, and I'm going to rearrange this and solve for y because that's just easier. So if I move y to the other side, I'm going to get 5x minus 10 is equal to y. So I move 10 to the other side and y to the other side. Our second step is we're going to sub the equation we just found, A, into B. So this is B. And I just found what y is equal to right here. I'm going to plug in 5x minus 10 every time I see a y. So this y is going to be replaced with 5x minus 10 instead because we found that in part 1. Now we want to simplify and solve for the variable. In this case, it's going to be x. So once I simplify, I'm going to get x squared plus x. This negative 2 is going to go into the 5x and into the negative 10 through multiplication. So that's negative 10x plus 20. Continuing to simplify, we have x squared minus 9x plus 20. And if we want to solve for x, we are going to factor this, same thing as our quadratics unit. So this is going to be x minus 5, x minus 4. 5 times 4 is 20, and negative 5 plus negative 4 is negative 9 to get the middle term. That means x is 5 and 4. Now we're going to find y. So y is equal to 5x minus 10 from our first step. I can replace this x with a 5 to find the y value, and I'll replace it again with 4 instead. So we're going to get a y value of 15 here. Therefore, we have one answer where x value is 5 and our y value is 15. And then we'll do it for the other one. But in this case, x is going to be 4. And this is going to be 10. So therefore, our other set, that's our answer, is going to be 4, 10. So our x value is 4, our y value is 10. And I'm stating it as coordinate points. You could also state it as x equals 5, y equals 15, and x equals 4, y equals 10 if you wanted to. So this is one method of solving for a system of equations. Another method is called elimination. So our goal here is to eliminate one of our terms so that all we have to solve for is just y or just x. And usually you want to stack them on top of each other so we can eliminate one or the other. So I'm just going to write a note. So we want to remove a variable. In this case, let's just remove y. And you could also remove x if you want to, but it's probably easier to remove y because the other one would give you an x squared as a remaining one, and that would be a problem. So to do that, we need to make sure that these guys look the same. This case, they're almost the same, but one of them has a -2. So I'm going to multiply one of the equation, which is equation A, by 2. So this would give us -2y in both A and B for our equations. So our A was 5x minus y is equal to 10. Now I'm going to multiply both sides by 2 so that I can get that -2y that we also have in B. So this is going to be 10x, 2 times 5x, and then 2 times -y, which is -2y. 10 times 2 is 20. Okay, so that is A. And then I'm going to overlap it. Oh, step 1, step 2. Overlap as vertical subtraction. For A and B. So A, we just wrote it as 10x minus 2y is equal to 20. And then for B, I'm going to write this underneath and align all of my terms. So I aligned it so that my terms, terms are shared vertically here. And then we're going to subtract these. And once we subtract it, we're going to see that our -2y term is going to disappear. So we have a nothing times x squared. It's going to give us -x squared. 10x minus x is 9x. -2y minus -2y becomes -2y plus 2y, which is just nothing, it's 0. And then 20 minus 0 is 20. Now I'm going to rearrange this because this is the equation I'm going to use now. So here I'm going to rearrange. I'm going to factor out the negative. Now what we have here is the same thing as what we had over here. And then we want to solve for x. Then once we factor this, we're going to get 5x minus 4 is equal to 0, which means that x is equal to 5 and 4. And then if we went through it again, we're going to get the same y value. So the next part is to find y, and we've done that already, so I'm just going to write out what we found before. We had the 0.515 and the 0.410. So basically, it's the same thing as this. Our last part is to verify our solution. So sometimes the solutions that we found when using the substitute and elimination aren't actual real solutions to the system of equations. And we're going to do it for both sets of points. So I'm going to check if 515 is one of them. We're going to check it for equation A and also for equation B. They both have to be satisfied for 515 to be a solution. So we're going to insert 515 into A. So A was 5 times x, in this case x is 5, minus our y, which is 15, and this is supposed to be 10. Then we have 25 minus 15, which is 10, and that's equal to 10, so this works out. Now we're going to do for equation 2. So we have x squared, so that's 5 squared, plus x, which is 5, minus 2 times y, in this case is 15, and we need this to be to 0. So 25 plus 5 minus 30 is equal to 0. 30 minus 30 is 0. So this is good. 515 is a solution. Now we're going to do it for 410. So for equation A, we have 5 times x, which is 4, minus y, which is 10, and this needs to be 10. This is 20 minus 10, which is still 10, so it works for equation A. Then we'll check it for B. Equation B is x squared, so that's 4 squared plus x, which is 4, minus 2 times y, so 2 times 10, this should be 0. You have 16 plus 4 minus 20, that's 20 minus 20, which is 0. So it works out for both 515 and 410. We can do another example here. This one's a bit more complex because they're both quadratics. We're going to do the 2 different types of solving. So we could do for substitution. And we'll also do it for elimination as well. Okay, so for substitution, our first step is to rearrange either A or B. So we're solving for x or y. And again, it's probably easier to solve for y. So step 1, rearrange A, and you don't have to do A, you could also do B, it doesn't matter. So once I rearrange this, I'm gonna move it around so I'm solving for y. So I'll just move y to the other side or add both sides with y. And this is what we're going to get. Step 2, we're going to insert A into B. So B is 6x squared plus 4x minus y equals 4. We just found out that y is also 3x squared minus x minus 2. We're going to insert that in for y. Now I'm going to simplify. This negative is going to change my sign for 3x squared, that negative s into a positive x, and this negative 2 to a positive 2. And I'm going to continue to simplify and collect my like terms. So 6x squared minus 3x squared is 3x squared. 4x plus x is 5x. And then I'm going to subtract 4 on both sides. Then we get negative 2. From here, we want to solve for x. So according to our last unit on quadratics, we could either solve this by factoring or using the quadratic formula. Now, you can try to solve this by factoring, but you're going to see that it's not really going to work out for you. So we are going to use the quadratic formula here. So that's going to be negative b, and our b value is 5. Plus or minus the root of b squared minus 4ac all over 2 times a, which is 3. Now we're going to simplify this. 25 is 5 squared. 4 times 3 times 2 is 24. Negative times negative is a positive. 2 times 3 is 6. 25 plus 24 is 49. And the root of 49 is 7. So in decimal, our number is going to be 0.3 repeating for -5 plus 7 divided by 6. And then -5 minus 7 divided by 6 is -2. So these are our two x values. Now we're going to find y. That's our step 5. And we can use a highlighted A from the first step there. So we have 3x squared minus x minus 2 is equal to y. And we have two different x's. So we can do -2 first. And then simplify. So you have 3 times 4 plus 2 minus 2, which is 12. So that's one point of -212. And the other one, we're going to use 0.3 repeating. You can use your calculator to help you with this one because it is a decimal. So if you put this into your calculator, we are going to get -2. So therefore, we have another point at 0.3 repeating -2. Now we're going to look at the elimination method. So we want to eliminate one of our variables. The easiest one to do is y. And here we don't have to multiply anything to a or b because we have -y in both of them already. So all we have to do is subtract those two equations. And I'm going to write it like a vertical subtraction, making sure all my numbers line up. Make sure your terms line up as well. And I'm just going to move this 4 to the other side. So when it's on the left-hand side of the equal sign, it becomes -4. And I'm going to subtract it all. Okay. So 3x squared minus 6x squared is -3x squared. -x minus 4x is -5x. -y minus -y is 0. Then we have -2 minus -4. That's -2 plus 4, which is 2. Zero minus 0 is 0. In our second step, we're going to rearrange and solve for x. So then we have now -3x squared minus 5x plus 2. I could factor out the negative. And then you're going to see this part here is the same thing as what we had over here. So then you're going to do what you did over here where you solve for x using the quadratic formula. And then I'm just going to say refer to and draw an arrow to what we just did because it's exactly the same work and you're going to yield exactly the same answer. And then your fourth step is to find y. And again, refer back to your substitution method because you're going to get the same answer. The last thing we're going to do is check to see if those 2 points are actually the answers to our system of equations. So we're going to check negative 212, and then we'll have to check 0.3 repeating negative 2. So we're going to plug this into A, and we're also going to plug into B to make sure they are both satisfied. So for A, we have 3x squared. In this case, our x is negative 2 minus x minus y minus 2, and this has to equal to 0. And if you go ahead and do this calculation, you can put this in your calculator if you want to, because we are using calculator for this question. This is 0 equals 0. So it's good. Our next one is 6 times x squared plus 4 times x minus y, and this should be equal to 4. So you're going to solve for our left-hand side, and hopefully this is equal to 4. And then if you simplify all this, this will actually equal to 4, so we are good. Now we're going to check we're going to check 0.3 repeating negative 2. We're going to plug into A and B. This one for sure use your calculator because we have decimal places here. And put in as many decimal places as you can for 0.3, because it's 0.33333 repeating. Put as many decimal places as your calculator will allow. So then for A, we have 3 times x squared minus x minus y minus 2 is equal to 0. So put this in your calculator, and if you do that, you will get 0 back. So this one's good. For the next one, we have 6.3 repeating squared minus 4 times 0.3 repeating minus our y, and this should be 4. Put this in your calculator, and it will give you back 4, and that's what we needed, and that's good. So happens that our two answers we found using substitution and elimination are good.